So I'm sharing my slides. Okay. So in the last class, in fact, till now, what we have studied is that we have seen that electrical communication basically started sometime in the 19th century. It basically started with telegraphy system. That was the first, we can say that is the first electrical communication. Before that, whatever communication were there, they were not electrical. So they are actually not of our interest, because we are we are actually interested only in electrical communication, where we are using electrical means of sending the signal. So we'll be using electronic devices and all those things. So telegraphy was a very basic way of doing the communication. In fact, there was no electronics in it. Okay. And then in the last half, in fact, in the uh, second last decade, you can say, that time in of the 19th century, that time when Alexander Graham Bell came up with his telephone. Okay, that was basically one big invention, you can say, because telephone, you know that it is still in use. Okay, although not in that old form, but still we are still using telephone because we cannot do away with it. Because voice is the main communication medium. Is we use speech. That is the main message, the form of message that we always want to transmit from one person to another. So obviously telephone will be always there. You cannot do away with it. Maybe it will be developed over times. Okay. So telephony was the main yeah, that time. In fact, that time people were using telephony for communicating. What's the yeah, telephone using their voice. Okay, so that was like one-to-one talking. So for that, telephony was used. But whenever people used to send some message from one point to another, then that time telegraphy was used. Okay, so telegraphy was used for sending a message. Like for example, in that time when these news agencies, okay, news agencies used to send their information from one place, some news to their editorial office. They used to use telegraphy system, okay, because they are not going to narrate the story, obviously. So they have to write down the things and then send it. But that has to be transmitted soon. So they cannot send it as the using letter or something like that. So telegraphy was used for that purpose, and telephony was used for face to face, not face to face, but the speech communication, direct talking. For that, telephony was used. So basically, that time these two communication things were there. But the problem that, as I already said, that the problem was that that time that people were thinking that how can I do this communication over a long distance without using cable and all these things. Okay, because for example, when a ship is sailing, and if the ship wants to communicate to the land, they cannot do it. Okay, if there is, because telephony and telegraphy was using cable and all this thing. So that time this was one problem, one hurdle in the communication, and that's why many people in the last decade of the 19th century, many people were trying to find out this radio wave communication. They were researching on radio wave communication, and that also we have already discussed that how things develop. Anyway, going back to again telegraphy and telephony system to some extent, just one slide basically. We want, because this is the basis actually, that there are different modes of communication, modes of transmission. Okay, and these are the different modes of transmission can be categorized as simplex, semi-duplex, and duplex mainly. Okay, what is this? Simplex is one-way communication. That means you can only transmit in one direction, from one station to another, from one user to another user, just in one direction. So it is like a one-way traffic. Okay. For example, this TV broadcasting. Okay. TV broadcasting, obviously, you know, at home you can receive it. You cannot send anything. Okay. So that is a simplex mode of communication. And the first form of telegraphy system was basically a simplex system. That was the first telegraphy system that was developed. Was a simplex system. You have the transmitting key at one end. You use that key for transmitting the Morse code, and in the other end you will be having a printer or the receiver, telegraphic receiver, which will receive it. You cannot, because these two systems are completely different. The receiver cannot transmit the telegraphic message. Okay, so it was just one-way communication. It was like that. Okay. Then in recent times, I don't know whether you know pager. Just sometime back there was something called pager. Nowadays, although pager is not used, this pager was that time used by, for example, this courier agent. Okay, this courier agent used to go and deliver the courier packets to different houses. Okay, different offices, different houses, and this courier agent will be going around, roaming around in the city, and the courier office, they need to contact this agent and send the address or something, that agent has to go and pick up a delivery from some address. So that time this office is to send a message, you that address in the pager, and these courier agents used to carry that pager, and in that pager that will be just coming as a message that you have to pick up a delivery from this address. So, but that agent cannot reply that. So pager was a simplex system. Okay. So that pager nowadays is not used, because mostly nowadays, you know, mobile phones are used. Even the courier agents, they are using mobile phones. All the delivery boys, they are using mobile phones. But pager was used sometime in the last decade of the previous century. Sometime around that 90, 98, 99, even that time. I have seen people, even in the first decade of this century also. That time also I have seen many of these people using pager. Okay. So that time actually mobile phone was not that much popular. So that's why this pager was used. Another very good example of simplex communication is that keyboard in your computer. Here you are transmitting the whatever you are typing, the message from your keyboard, you are transmitting to your computer CPU. It is one way. You cannot get back anything from that to your keyboard. Okay. So these are all simplex one-way communication. Semi-duplex was a one step ahead of this simplex, where you can have two-way communication, but not simultaneously. And that was actually in the telegraphy system. It was because then people felt in the telegraphy system that one-way communication is not useful. Okay, so then they made some development, and the development was that at a station you have both the receiver and transmitter, but you just switch from one to the other. When you are transmitting, you will be connecting to the transmitter. When you are receiving, you will switch to the receiver. So there will be something like a switchover from transmitter to the receiver, and accordingly you can have the communication, two-way communication, but you cannot have both of them together. And walkie-talkie, that is another good example of semi-duplex. And you know, maybe you know that when people used to use walkie-talkie that day, nowadays again, walkie-talkie is not used, because mostly again mobile phone is used. But walkie-talkie, when in earlier days, maybe nowadays even, I don't know whether you have seen it, but when people are using this security people, then your police, all these people, then even defense also, when people use this walkie-talkie, you might have seen it in the movie or somewhere also, that when they talk, after completing their whatever they want to say, after completing their speech, they will say over. Okay, and once they say over, that means he is finished. he or she is finished, then he will switch off from the transmitter and switch on to the receiver, and then on the other side the person will now start transmitting. So there is actually again that switchover will take place from receiver to transmitter. Okay, so that's why that over, that has to be said in the walkie-talkie. Once you say over means you are done. So then the other person will now stop the receiver and now go to the transmitting mode. Okay, so like that. So that was semi-duplex method of communication. Duplex is obviously the one which we are still using, and that is what we are using nowadays. This is the two-way, simultaneously two-way communication. Okay, and the telegraphy system was developed to a duplex system. Telephony system obviously was also developed to a duplex system, and nowadays you know all the telephones are basically, even there is no walkie-talkie, nothing like that used anymore, and all are all duplex telephony system where you can keep on talking. In fact, at the same time you can the person from this end can say something to the other person, and the person from the other end also can say something. Okay, so that is possible in a duplex system. Mobile phone itself is a duplex system. Just two special types of system which was actually developed by Edison for this telegraphic system. Actually, he developed it. Just you may be knowing that Edison was working in a telegraphic office, and while working there, he developed many things. And in fact, he is the person who is holding the maximum number of patents for developing, inventing many things. Okay, so one thing he developed was a duplex telegraphy, because when he found that this telegraphic system, simplex telegraphic system, was not good, means it was not able to transmit many messages. So he developed a system where two messages can be transmitted simultaneously, but in one direction. Okay, so it was, you can say it is 2 into simplex. It is a simplex system, but two messages at the same time. He developed something. We are not going into details of all how he developed all these circuits and all these things, but he developed it. Okay, so that you can find out in any telegraphic book. It is given the duplex system he developed, where two messages can be transmitted, but in one direction. Okay, so it obviously will increase the efficiency of the telegraphic system. And then he later on he modified the duplex system to quadruplex system, where you have this two messages going in one direction, two messages coming in the other direction at the same time. So you can say it is somewhat like a duplexed duplex. Okay, so this was again developed by Edison. Okay, so these are basically some of the modes of transmission. Just now one question may come to your mind, that how in that time is in this telegraphic system and the telephonic system, which were basically just an electrical circuit. It was just an electrical circuit. How it was possible to have the duplex communication? That means at the same time you have messages coming in two directions. So there will be obviously these two messages coming in two opposite directions. They will obviously create an interference. So how that can be, how that was handled, is how the circuit was developed. In fact, there are many different types of, not many, but there's some 3 or 4 different types of duplex system was developed for telegraphy as well as for telephonic system. I'll just give one example to give an idea how duplex system is to work. Okay, so this is one just example of duplex system working. Okay, that how you can have two messages going in two opposite directions. So you will be receiving the message from the other end, at the same time you can transmit the message from your end. Okay, the basic principle behind this working of this is the bridge system. I think you know this, you have already studied it, that Wheatstone bridge and all these things you have already studied in your physics class 12. Okay, so you know. Okay, so this is a bridge system, and you know that if I have a galvanometer here, this galvanometer will show if some current is flowing in this connection or not. If this is the condition satisfied, that Z1 by Z2, Z1 is the impedance. You have studied it as resistance in class 12. So now I am just generalizing it. Instead of saying only resistance, I am saying that it is impedance. If impedance Z1 by Z2 is equal to impedance Z3 by Z4, if this condition is satisfied, then the galvanometer will show no deflection. That means no current will flow from this point to this point. Okay, so that is the condition, and that condition we actually, this principle is used in this system. Okay, so this is one telegraphy or telephonic system, whatever it is. Okay, in both the systems actually we use the same principle. Okay, so this is one end, this is the other end. Okay, now suppose I want to transmit from this end to this end. So I will close the switch here. I have shown it as a switch. Okay. So I close the switch here. Okay. So it will give you some signal transmitted. I am just basically I am drawing it. So this is just like a message signal, a message source. Okay. This is a message source. So I want to transmit something from this end to this end. Okay. So I close the switch. So it is like the transmit. Now the thing will be transmitted. Now this ZDB, it is dB is the short form. I am using it for duplex balance. It is used for duplex balance, for balance, maintaining a balance condition for duplex transmission. That's why we are calling it duplex balance. So this ZDB is designed in your circuit in such a way that Z1 by Z2, these are the impedance that will be offered at by your transmitter. Okay, the circuit in your transmitter will offer some impedance Z1 and Z2. So I am just putting it as a simple circuit. So this Z1 by Z2 should be equal to ZL plus ZS. ZL is the impedance of the total line and ZS is the total impedance of the other end circuit, the total circuit. Okay, whatever it is, the you can say this is the overall impedance of this circuit, the effective impedance of this whole circuit. Okay, so whatever is the ZS, the ZS plus ZL. Okay, so this ZS plus ZL is somewhat like your Z3 in this balance. Okay, in this bridge Z3, and Z4 is somewhat like your ZDB. So if you look into this circuit like that, then you see that if this condition is satisfied, then there will be no flow of current from this point to this point. No flow of current from this point to this point. And this is where your receiver is connected. That means you are transmitting the message, but the balance condition, the impedances are balanced in such a way that your message, your own message, will not go through your own receiver. Okay, it will not go through your own receiver. Similarly, on the other end, that when this person will be transmitting, this signal will go in this direction, but that signal will not pass through the through this. The signal will not pass through its own receiver. When both the people are transmitting, when both the ends are transmitting, now you see, you know the superposition theorem. Okay, according to the superposition theorem, the signal which the message signal which is passing from here, that will not go here, but it will go in this direction, and then it will get divided here in one path along this and one path along this, and then it will go like this. Okay, so whatever the message here is, current proportional to that message will be flowing through this receiver. Okay, but this current will be, or the current through this will be only proportional to this message, because as we have seen that this one, the current due to this will not flow through this. Similarly, when this one is closed at the same time, whatever current will flow through this, that will be only proportional to the message signal here. So that is how the duplex system will be working, that you will not hear your own voice or your own signal, you will not receive your own signal, but the other end will receive your signal, okay? And by using that technology or that principle of bridge balancing, you can have the duplex working. Okay, this is just one type of duplex system. Okay, there are other types of duplex system, obviously. Okay, this is just for your understanding. Okay. Now there are certain questions. Okay, obviously some questions will come in your mind at this point. Is it possible to transmit telegraph and telephonic, that is telephonic means voice signal, over a long distance without much attenuation? Okay, so that was obviously that was the main question that arose that time. People were thinking over it, that okay, for a short distance I can send telegraphic message, I can transmit telephonic message, but what about transmitting it from one city to another? Okay, still that is possible, maybe to some extent, but is it possible to transmit telegraph, telephone, all these signals from one continent to another? So that was a big question. Okay, so obviously the answer is no. Attenuation will be there, although it is low frequency. So L and C will not cause much problem, which we have studied in the last class, transmission line. L and C may not cause much problem, but R and G, because it's a long distance, so R and G will obviously have some problem. Okay, it will give some problem. The resistance and the shunt conductance of the cable, that will give some problem. And also we have mentioned some time back that there will be radiation loss, because these cables, they will also act like somewhat like an antenna, so they will transmit some signals. Okay, so there will be some radiation loss also, so that is one problem. Okay, so in order to take care of that attenuation, so one thing that was obviously possible, and that is what people used to do that time before radio communication came. What people used to do is that people used to install intermediate relay stations, okay, to boost the signal power. Okay, so suppose I want to send some message from here to Mumbai, so maybe there will be a relay station somewhere in Meerut, somewhere in Delhi, like that. In different cities in between, I'll be having the relay station. But that will obviously add up to my cost. Relay station, I have to have relay station at every point, so that will add up to my cost and all these things. So all these problems are there. Okay. The next question that comes to the mind is that, can we transmit this telegraph and telephonic voice systems over a long distance wirelessly? Because if these are the problems, if in cable communication, if these are the problems, then is it possible to do it wirelessly without the use of cable? That was actually the main motivation behind the research in radio waves. And when people, that is what we have already discussed this, that when research in radio waves showed that it is possible to transmit high frequency radio waves, okay, wirelessly over a long distance. Okay, this started with smaller distance, but gradually the research people started first. They did this only just 75 feet. They transmitted it over a distance of 75 feet. That is what Jagadish Bose transmitted. Then later on, people started developing that one, making it better and better, and then finally people were able to transmit it over a very, very long distance, this radio wave. And that is what actually led to the invention of radio system by Marconi. Marconi patented it. Okay. So this is what we have already seen. Okay. So now, but there is something also we have studied, that it is not only wireless communication, radio waves or the high frequency waves, electromagnetic waves, that can be also transmitted over transmission line and waveguides for point-to-point communication, because that is what we mentioned also, that when we are doing wireless communication, it is not point-to-point. Okay, you are just basically throwing away your signal in the air, and your receiver has to just pick it up from the air. So it is not point-to-point. Whereas I can make it point-to-point by using a guided medium, and that guided medium, as I said, transmission line, but not good for very high frequency. It is okay for till some frequency, but not very good for very high frequency. Then we have seen that there is something called waveguides that we have studied already. Okay, to some extent we have studied. So you can have point-to-point communication over a long distance, and you can use radio wave communication for that. So radio wave, which was developed in the last decade of the 19th century, and people were doing more and more research even in the first few decades of the 20th century. People developed this radio wave communication system, which can be used for transmission not only wirelessly but also guided medium. Okay, and even nowadays, you know, not a guided medium is there, fiber optics and all these things they are also using. Okay, that also I have said in the last class. Now the question comes that when I am doing wireless communication, now this wireless means the air, the free space belongs to everyone. So suppose I am sending something to someone, and another person at the same time is throwing his or her message in the air in the same medium at the same time. Now, will there not be some problem? Means will not my message and the other person's message will get mixed up in the air? And if so, that is not only two people. There are so many people in the whole world transmitting message at the same time in the same space, same air. So there is obviously a possibility that all these messages will just get mixed up. Okay, then how to take care of that? And mixing up all these messages means it is the crosstalk. I will be hearing message of the other person that will get mixed up with my message and all these things. So all these problems will be coming. So that is the crosstalk or the interference. Okay. Another question. Now, can we do two-way transmission? That is the duplex transmission over the same dedicated line. That means using the transmission line, waveguide. Can I do duplex transmission? That is another question. Because again, in the duplex transmission, if it is connected between two person, then if I am sending a radio wave over that, the other person, if it is sending a radio wave, how can I take care of that? Because what people have developed in telegraphy and telephony system, as we have seen, it was just for that electrical circuit. It was just like an electrical circuit, and they were doing some electrical things, that Wheatstone bridge principle and all these things. That cannot be used for your electromagnetic waves. Okay, because you know the waveguide that we have seen in the last class. Waveguide is what? It is just a hollow path through which the electromagnetic wave is traveling. That's all. So you cannot just do all these things. That circuit analysis will fail there. Okay. So can I do this duplex transmission in that type of case? Another question. Is it possible that not only just duplex transmission, is it also possible that I use a single line connecting, say, two cities, and then many people from this city, can they connect to many people from the other cities over the same single line connection? Okay, because earlier days we used the connect, as I said, I mentioned it in some class earlier, that there used to be, say, 10 lines, 10 telephonic cables connecting Delhi with Mumbai. So at a time, only 10 people can talk to one person in Mumbai and one person in Delhi. So only 10 pairs of people can talk at a time, because there are only 10 cables connecting these two cities. But now, is it possible that if I have only one single medium connecting Delhi and Mumbai, maybe wirelessly also connecting Delhi and Mumbai, so is it possible that multiple people can talk over that single medium at the same time? Answer to all these three questions is multiplexing. There is something called multiplexing which we can use, and by doing this multiplexing, many people can transmit their message over the same transmission medium, whether wirelessly. Wirelessly means that it is a single medium only, the whole air. Okay, so it is possible there, or even if it is a guided medium, but that guided medium can be used by multiple people. So if it is a cable, coaxial cable connecting two cities, I can transmit many messages over the same coaxial cable without interference. If it is a waveguide connecting two stations, I can transmit many messages at the same time over the same cable in both directions. Okay, so that is the purpose of multiplexing. Okay, we'll talk about that. Okay, then another question, that radio waves are high frequency. Radio waves are high frequency waves. Okay, but this voice signal, the telephonic signal, the voice signal is low frequency. Maximum frequency of our voice is 3.4 kilohertz. Note it down, 3.4 kilohertz. That is the maximum frequency of our voice. And audio, if it is audio, high frequency music and all these things, maximum audible audio frequency is 20 kilohertz. Okay, 20 kilohertz. So 3.4 kilohertz is our voice signal, 20 kilohertz is the maximum audible audio frequency. Okay, so these are low frequency. Radio frequencies, radio wave frequencies are very high. So now we are already saying that it is possible that if we go for wireless communication using radio wave, then it is possible to transmit over a long distance. But voice itself is not high frequency. So that means what we have to do is that we have to translate these low frequency signals, telegraphic signals, they are also low frequency because you have pulses manually, you are doing it. Okay, 0, 1, this dot dash, you are doing it manually. So obviously that will be having very low frequency transitions. Okay, these pulses will be coming at a very low frequency. It will be square wave type, but low frequency. Okay, so this type of low frequency signals, okay, that cannot be transmitted in the form of a radio wave. Okay, so what we have to do, that low frequency telegraphic voice signal and the voice signals or telephonic signals, they need to be translated or converted to high frequency radio waves. It is required, and the process for doing that is called modulation. Okay, so these are the two things that we will be looking into: what is multiplexing and what is modulation. There are different multiplexing schemes. Okay, so multiplexing is basically sharing of the channels among multiple signals or multiple users. So multiple signals will be transmitted over the same channel. For what? It will obviously give you economy. You need not to have many cables connecting two cities. You can have a single cable connecting two cities, but multiple people can use or share that single medium. So there is obviously some economy in it, and that obviously consequently you will be having the maximum utilization of the network. Okay, some of the multiplexing schemes, one that we will be obviously studying and which is the main multiplexing scheme that is used, is the frequency division multiplexing. Okay, we will talk about it. What we do, the total spectrum or the bandwidth available, okay, that total bandwidth available is divided into smaller frequency slots, and different users, different broadcasting stations are allotted different small subbands or slots, frequency slots. So that's why it is called frequency division multiplexing. The frequency range, the total frequency band is divided. Okay, that's why it is called frequency division multiplexing. Time division multiplexing is actually used in digital communication that we will study afterwards. Digital communication, where the total time is divided into small slots, time slots. Okay, in one time slot, I transmit one bit. You know, digital communication takes place in the form of bits. Okay, bits, zeros and ones. So in the same time, say in one time period, bit period, I that one bit period is divided into 10 small slots. Okay. So in first slot, I send one bit from channel 1, then channel 2, channel 3, channel 4, like that. From 10 bits from 10 different channels, I send it one after the other by dividing the total bit period in 10 slots, 10 time slots. So after that one bit period is over, then by that time the next bit from the 10 channels are ready, and again I push it in 10 small time slots. So that we will discuss afterwards, okay, how it is done. So basically time division multiplexing is where we are dividing the time in slots, time slots, and allocating different time slots to different channels. Okay. Code division multiplexing is also used in digital communication, where the message that is transmitted is coded differently. Different messages are coded differently, and the intended receiver will pick up the message that it wants, the message that is desired by a particular station. That intended receiver will pick up that message by decoding that using a particular decoding key, will pick it up. Other messages, it cannot pick it up because it doesn't have that key to decode the other messages. Okay, so like that, code division multiplex, multiple access. So that is again used in digital communication. That we will not study in this course. You will study it afterwards when you will be studying your digital communication. This is just for your reference. I am giving you the name. A modification of the frequency division multiplexing is the orthogonal frequency division multiplexing. Again, this one we will not study now. We will study it afterwards in your digital communication course. Okay. So this OFDM is actually used for better spectral efficiency. That means the bandwidth is utilized better. Okay. The frequency band is utilized better. You can push in more number of channels in a small band. Okay, frequency band. And still better than that, OFDM is the non-orthogonal multiple access, which is a recent development, and this is even better than the orthogonal frequency division multiplexing. So this again will be not studied. So basically we will be studying this FDM and TDM. TDM we will study later on. Now what is this FDM? Just a basic idea that this bandwidth of the transmission medium is generally very high. Okay, for example, this transmission line, they can carry your signal up to some megahertz. Okay, they can carry the signal up to some megahertz. Okay, your waveguide, they can carry your signal. The bandwidth is up some gigahertz. Okay, some gigahertz. And so you know that the large bandwidth can be handled or transmitted over the waveguide. Okay. Similarly, the free space, the air, that can handle very high frequencies, up to very high frequencies, terahertz also. Terahertz means 10 to the power 12 in that range. Okay, 10 to the power 12 hertz in that range. So it can handle that high frequency up to that high frequency. But I don't, my voice is only 20 kilohertz. Zero, if I said, if I consider zero, although it is from 20 to 20 kilohertz, but we can still say it is 0 to 20 kilohertz. So actually my voice is only 20 kilohertz. Whereas, say this my air, it can take your signal, the bandwidth that is possible to transmit it is in the range of 10 to the power 12. So you can see that actually I need only a small narrow band for transmitting my signal, but the available band is very large. So what I can do, I can divide this whole available band, transmission band, okay, that I can divide into small slots and allocate it to different stations, channels, different users. I can allocate it to different people, okay. So that is what the frequency division multiplexing can do, okay. And by doing that, it can now transmit many messages over the same medium, okay. So this is what I have written here. The available bandwidth of the transmission medium is divided into a number of narrower frequency bands, which we call it subbands. Each of these subbands is allocated to each user or transmitting station. Okay. So this is just a pictorially I am showing that this is a band, subband with the center frequency F1. This is another subband with center frequency F2. So like that I can have many subbands, 6 subbands I am showing here. So the same radio station is can transmit 6 messages at the same time using 6 subbands. Okay, in 6 subbands. Okay, this is a mobile way that you use. When you are, this is the duplex system, how the duplex system is working here. When this base station is transmitting the message to you, the base station is picking up a message from this, say Bob wants to talk to Eve. Okay, so Bob will be transmitting the voice in a subband with frequency F2. Okay, the base station will pick it up, then base station will divert this signal to Eve using the subband frequency F3, different frequency. Eve will now give a reply that will be now transmitted to the base station using some other frequency F4 and will be now diverted to Bob using another frequency F1. So you can see how different frequencies F1, F2, F3, F4. These are 4 different frequencies of 4 different subbands. These are basically the mid frequencies of the 4 subbands. Okay, these bands are smaller narrow bands. Okay, and these are the mid frequencies. Okay, so there will be no overlapping of the message, but all these messages are there at the same time in the air. They are there, but they are not mixing up different frequencies. What Bob will do, Bob will have a receiver tuned such a the receiver will be tuned such that it can only select this F1 frequency signal. It will pick up the F1 frequency signal from the air, and when it transmits, it will be transmitting at F2 frequency like that. Okay, so this is how the frequency division multiplexing takes place, which will be clearer when I go to the next few slides. It will be much more clear to you. Okay, so how this frequency division multiplexing takes place? A carrier signal of appropriate frequency, which is the center frequency of the subband. That is what I have mentioned here. F1, F2, F3 like that. These are the carrier frequencies. Carrier signal. So this will be the frequency of the carrier signal. And that frequency is the mid frequency of that subband allocated to a particular transmitting station or user. And this carrier frequency, carrier signal is modulated. It is modulated by the message signal from that station. So that means here, sorry, here when Bob is talking, the voice of Bob is the message, which that voice, which is only 20 kilohertz, okay, up to 20 kilohertz. Voice is in fact up to 3.4 kilohertz. That small low frequency signal will modulate a high frequency carrier wave of frequency F2. Carrier wave will have a high frequency F2. That high frequency F2 signal will be modulated by that low frequency message voice of Bob. Okay, and that will get translated. This low frequency will get translated to a high frequency F2. That again we'll see how it is actually done. Okay, mathematically we'll see how it is possible that it gets translated to a different frequency. That we'll see afterwards. But this is for the time being. You just know in this way that there is a process called modulation. That modulation will do this frequency translation. Thus, the message is inserted in that subband in the form of a modulated wave. There is a carrier wave corresponding to the midband frequency of the subband. That carrier wave is modulated in accordance to the message signal. So the modulated wave is actually carrying the message in it. Okay, the modulated wave is carrying the message in it. Okay, what is the modulation? The modulation is basically something of that carrier wave is changed. Something is changed, and that change is proportional to the message. So when you get that modulated wave, you will look into that what change has taken place, and from looking into that, observing that change in that modulated wave, you know that what the message was, because the change is proportional to the message. Okay, that is how it takes place. Okay, and that next point is that obviously we'll try to have some guard band so that there is no interference. Okay, that will be clear if you look into this picture. This is the frequency division multiplexing picture. Now, at this point, I want to mention something, because otherwise this picture will not clear to you. You have any signal. Okay, I don't know whether you have studied Fourier series. If you have studied Fourier series, you know that any function can be written, or you can split it in the form of sum of many sines and cosines. Okay, Fourier series will give you. So basically, Fourier series is the basis of this. Okay, you will study Fourier transform also later on. So actually, any arbitrary signal in this whole world, whatever arbitrary signal is there, any arbitrary signal can be always decomposed into a set of many sinusoids. Okay, and these sinusoids will be having different frequencies, different amplitudes. So basically, I can say that any arbitrary signal is the sum of many sinusoids of different frequencies and amplitudes. Okay, and a plot of this for representing that signal, I plot the amplitude versus frequency. That is called the spectrum of that signal. This we will use it again and again afterwards, because generally as a communication engineer, we look into the spectrum of a signal rather than we look into the time domain or the time function of the signal, that how the signal is changing with time. It doesn't matter much to a communication engineer. What it matters much is that what are the frequencies present in that signal, and to what amplitude those different frequencies are present. That means how that signal is made up of different frequencies. And that is what we call spectrum. So these are the example of the spectrum that I am showing here for 3 different messages. Okay, this is just arbit drawing. Okay, I am showing it in the form of triangle. It means that the signal M1, this is the first signal, the signal M1 is having some frequency from this to this. Okay, defined frequencies are present from this to this, and the amplitudes of the defined frequencies are in this. Okay, they are gradually decreasing. Okay, that's why I'm drawing it like this. Now this is the zero frequency. Generally, we draw the spectrum both positive and negative frequencies. You know, cos 2 pi ft is as good as cos of minus 2 pi ft. So positive frequency and minus frequency are equally good. Okay. So generally that's why in for mathematical convenience, later on you will see that for mathematical convenience in all our analysis, we always represent a signal in both positive and negative frequency. Okay, because that helps us in doing our mathematical analysis. So the spectrum is also drawn with positive and negative frequencies. So this is the spectrum of message 1. Similarly, say this is the spectrum of message 2, and say this is the spectrum of message 3. Now you see this, all these three messages are in the same frequency range. Okay, this is the voice 0 to 3.4 kilohertz. So it is like 0 to 3.4 kilohertz is my voice. This is 0 to 3.4 kilohertz is the voice of another person. This is the voice 0 to 3.4 kilohertz is the voice from a second person. So they, myself and two more person are talking at the same time, and these three voices are to be transmitted over the same channel. Maybe it is wireless transmission over the same air. It has to be broadcasted, it has to be transmitted, communicated. So now if I throw all these three signals at the same time in air, then you see that they will just mix up, because all of them are having the same frequency range, so they will just mix up. So that is the problem, that is the crosstalk that we will be having. So what we do by the process of modulation, as I have mentioned, this frequency will be now translated to the midband frequency F1 of channel 1, and it will be translated like this. Okay, modulation process will do that. We'll study that afterwards, how it is done. This one will be translated to channel 2 with midband frequency F2. Okay, and this is channel 2. So basically the subband, this subband, from this to this subband is allocated to channel 1. This is the subband, a defined frequency range subband is allocated to channel 2, and a defined frequency range is allocated to channel 3. So three defined subbands of different frequency ranges are allocated to defined channels, and their midband frequencies are F1, F2, F3. Okay, we do the modulation, and after doing the modulation, now if I throw all this signal in the air at the same time, I will be having these signals now positioned like this in the frequency band. Okay, so you now see that when these three signals will be traveling in the air, they will be not interfering with each other. They will be not interfering with each other. Now, whoever wants to listen to my voice will now have his receiver tuned to pick up. There will be filter. There is something called filter in the receiver. That filter can select only the frequencies signal corresponding to the frequencies from this range to this range. Okay, and accordingly, he or she, my intended receiver, will pick up only my voice and reject all the other signals that is in the air. This is how the frequency division multiplexing takes place in communication. Okay. So last, this scheme is used where, you know, it we'll see later on that it is used in radio. You know, in radio you have different radio stations. Okay, and they have some frequency. In fact, in when you listen to FM radio, they say 93.4 kilohertz or megahertz, something megahertz, I think 93.4 megahertz frequency, like that they mention it. Okay, so that is actually the frequency that I am talking about. F1, F2, F3, that is the frequency. So different radio stations have different frequencies. Okay, similarly TV broadcasting, when you do the channel selection, the channel selection is basically the tuning to the different frequencies that I am talking about. That receiver tunes itself to a particular band and picks up only the signal from that band. So when you do the channel selection using your remote control in your TV, okay, set-top box, it is actually selecting a particular channel. So in TV broadcasting, you have all the signals. Your dish antenna is picking up signals from all the radio stations, all the television stations, but they are coming in different frequencies, and all of them are reaching your set-top box. They are all coming to your set-top box through the same cable from your dish TV to your set-top box. It's a single cable. All the signals are coming. All the signals are coming. All channels. They are multiplexed in that same line. They are multiplexed and coming to a set-top box. Now in your set-top box, using your remote control, you pick up a particular subband. So that means you are setting your filter in the set-top box to a particular frequency. So that filter will now filter a particular frequency signal. Okay. So TV broadcasting uses this. Okay. Then telephone lines, nowadays they are using it. Even your satellite communication, cellular networks, I have already mentioned that how your mobile communication is using all these things. So all this frequency division multiplexing is used everywhere. Even in your fiber optic communication also, we use it. For example, when your department, for example, in the department, we have so many labs, so many computers, all connected to the computer center. You know the computer center is there. I don't know. You might not have already. You might not have seen the campus yet. In the campus, we have a computer center from where the signal, all the emails, all the internets and everything is actually coming from the computer center, because computer center is picking it up from the outside the campus, and then it is delivering your internet, your emails, all these things are going to all the people in the campus. Okay. Now in our department, we have every faculty is having one computer. Every computer is there. In every lab is having many computers. Now all these computers are connected to the computer center, but you don't. There are some thousands of computers in a department, and you don't have thousands of lines connecting your department to the computer center. There is only a single line. There is only a single line connecting your department to the computer center. Okay, and that single line is a fiber optic communication. Okay, there is a fiber optic cable connecting the computer center to our electronics department. Okay, now how all the computers are accessing at the same time different messages. Messages will otherwise get mixed up. So that is again using this frequency division multiplexing. But just one point, that in case of fiber optic communication, we don't say it frequency division multiplexing, but we say wavelength division multiplexing. It is just terminology that is used in optical communication, because actually it is the physics people, they use wavelength and all these things. Physics people don't use frequency word very much. They use wavelength more frequently. So, and since fiber optic was developed mostly by the physics people, that's why they have used this word wavelength division multiplexing. Okay. The final sentence in today's lecture is that when multiple users are sharing the same communication channel using the frequency division multiplexing, this process is called frequency division multiple access. I think it is clear to you why it is called multiple access, because all the people are accessing, all the users are accessing the same channel using this method of FDM. Okay, they are either transmitting or they are receiving the signal using the same channel using frequency division multiplexing. That's why it is called frequency division multiple access. So that's about today's lecture. Next class we will start with the modulation. I'll just give you a basic idea about modulation, how frequency translation is taking place. This is how this frequency is translated using modulation. Next class we will talk about it. But next class means we will not have class on Monday, because Monday is a holiday for Uttarakhand. In Uttarakhand we have general assembly election. Okay, so that's why there will be no class on Monday. Next class will be on next Friday. Okay. Any question? If you are not having any question, then you can leave. Okay.
Thank you, sir.
Thank you.
Okay, welcome, and meet you on next Friday. Okay.